Dan Vanderweide. We're here with Microsanj at Radio and Wireless Week 2026, and we're demonstrating the ability to image the near zone electric field at 2.4 gigahertz on a variety of pixelated microstrip patch antennas that I'm showing right here. We've got 4 different examples, 2 of which are essentially identical, and one of which is not optimized at all, and the other is just a different variant. So those antennas are represented under here, where we are switching between activating them for 1 second and then letting them cool off for 3 seconds so that we can accumulate a differential image here that's shown on the right. So the live image, which you see springing up here on the left, is due to the antennas being activated with the 2.4 gigahertz signal. And what we see here is just the differential between hot and cold, essentially, so that enhances the contrast. What I want you to pay attention to is the fact that this antenna in the upper left is basically cold except for where it's being fed right here from the connector. And so the reflection of the RF energy back to the connector is what we see right around the connector, and there's nothing else there. What we see here in the second upper right panel is a more well-matched antenna, but one that is clearly not going to be a very effective radiator because the near zone is not uniformly distributed at all. What we see down here in the lower portion is we see those 2 identical antennas nominally, but one with the field oriented this way and one with the field oriented this way. So if I had imaged them both the same way, then we would see identical patterns in the near zone, but because I'm imaging orthogonal field components, you see a large distinction between the 2. So to summarize, what we're showing here is a live image of a 2.4 gigahertz near zone electric field magnitude squared that is being subsequently imaged by an infrared camera from the Microsanj EZ-THERM 500 system and presented in real time on the screen. So we're enthusiastic about how this can enable future diagnosis and better design of planar antennas.